Alrighty, good afternoon there, lads and ladies. Welcome to our first class meeting for MAC1140, which is pre-calculus. Hey, I hear my cat clawing at the door, so I'm going to go ahead and let him in, and then we will get started formally. So it's nice to see you guys turning your video feeds on. I really appreciate that. It's good to know that you're all here and present. Alrighty. So today is going to be a fairly simple day. We are going to do some mathematics because we have to. This course moves incredibly quickly. It's a 6-week class, which means we're taking the content of a normally 16-week class and just cramming it into the shortest amount of time possible. I'm going to try to respect your time by not wasting it. So you'll see here, I'm going to share my screen. It's going to go full screen on your device. I'll ask that you leave that as full screen so you can see what I'm displaying. First things first. This is the apparatus I'll be using to convey the notes, and anything you see me write here on the document camera is stuff that you want to put into your notes. Begin with the class, the date, and just a little introduction to what we're going to do. So today, we're going to do the standard first day stuff, and we have to go over the syllabus. I know syllabi are generally a little under-respected, but the truth is the syllabus is a contract between me and you guys, letting you know precisely what it is I require of you to earn a satisfactory grade in the course and what you can expect from me. The other things we're going to do are talk about the web components. Canvas and WebAssign. I know that the college algebra courses here at the college still, for the most part, use Pearson products. WebAssign is a Cengage product, so it's possible that you haven't used this before. Canvas, I hope that you've all experienced at some point in the past, but I'll be showing you just the little things that you'll need to use for Canvas. And then we're going to go ahead and we're going to get started on the course material. We're going to talk about section 2.1 and maybe a little 2.2 if there's time. So that's what we're going to be looking at today. The emphasis here, and if I'm honest, through much of the course, is on getting you comfortable with function notation. In previous math classes, they tell you that, f of x is replaceable by y, that they mean the same thing, that you can kind of ignore the function notation if you want to. It's really not true, especially as you move into calculus. Understanding functions as input-output pairs, and specifically working with the function notation becomes hugely important. So that's where this class is going to begin. We're going to make sure that you guys are really comfortable with what function notation means. That way you can manage all the different things I'm going to ask you to do with it as the semester progresses. But we're going to go in order. So first things first is the syllabus. Let's come over to Canvas real quick. So if you haven't already, of course you've visited Canvas, but if you have not already, please go ahead and come to this link in Canvas and download a copy of the full syllabus. The syllabus page in Canvas just has the absolute basics here. But I need everybody to have a copy of the syllabus to which they can refer. I have a copy saved, but you can just click that link and it will take you there. Save it somewhere on your computer. You can find it in the future. So here's the full syllabus for our course. It's a syllabus. This is pre-calc, summer B. The section number for this class is B01, and that's information that you're going to need from time to time. So please try to remember the section. It's not that hard. It's the very first section of summer B. So B01 is your section number. My name is John Filesticker. I'm an assistant professor here at Santa Fe College. The last name is pronounced Filesticker, but you can just call me John or Professor P or whatever makes you comfortable if you don't want to bother pronouncing that. My office is A031D on the Northwest campus. That's the main campus for Santa Fe. The location here is in Building A, and then you go downstairs on the north side. That's the 031. And then once you're in the office unit, you'll find me in Office D. I'm not going to be spending a lot of time in the physical office since I'm still working from home. But if you ever need to leave something with my secretary or have something given to you by my secretary, that's the place to go. So A031D, downstairs on the north side of building A. My email is here, and this is a mail to link. You can just click this and it'll open up an email for you. But you can also reach me through Canvas, and Canvas messages are better, if I'm honest, because they, in the subject line, they'll be forwarded to my email, and in the subject line, they'll say right there, you know, what class, what section, makes my life easier. So I would prefer, if you want to write to me, do so through a Canvas message, but if you want to send me an email, that's where you do it. Class meeting times, you guys probably already have this figured out because you're here. But we're going to meet Monday through Thursday from 1:15 to 2:50, and they're always going to be Zoom meetings. It'll be a different Zoom link each day, and I'll post that Zoom link for each day's class in the announcements where you found today's. Office hours, similarly simple, Monday through Thursday, 3 to 4 p.m. on Zoom. Or if you can't come during one of those, but you want to talk to me, you can make an appointment, and I'll send you a separate Zoom link. The link to get to the office hours is right here on our homepage in Canvas. If you come right here and click this link anytime between 3 and 4 p.m. on one of these days, you will be brought to a waiting room for a Zoom meeting. And you know, I'll probably admit you right away, but sometimes people want to talk about things privately, so I have to use the waiting room feature there. Final exam for this class is August 9th. And I want you to put this in the calendar on your phone right now. That's the way to do it. Just go ahead, grab out your phone. I don't mind. Grab out your phone, put this shit in your calendar, and give yourself a few notifications. Give yourself one like an hour ahead of time. Give yourself one like a day ahead of time. Give yourself one like a week ahead of time to remind you. You really don't want to miss this. It's super important. Final exam schedules here at Santa Fe are very rigid. We're not allowed to do makeups for those. So it's crucial that you come on time for that final. Prerequisites class, you got to get through college algebra with a C or better. The textbook we're going to be using is Stewart's pre-calc text. It looks like this. You don't need to buy a copy of this textbook if you don't want to. But if you would like to have a hard copy of the text and you're having trouble finding an affordable one, go ahead and reach out to me through a Canvas message. I can point you to a place where you can get one cheaper. My recommendation would be abebooks.com. That's Abe like Abraham Lincoln, books like books.com, all one word. You can usually find it on there for like 40 bucks, something like that, which is much cheaper than the bookstore will charge you. But again, you don't need a hard copy of the text. The thing you do need to buy is a WebAssign access code. So you must actually purchase one of these. They're about 100 bucks, depending on how you do it. And once you're into WebAssign, there will be a copy of the textbook there, an electronic copy that you can use. If you haven't purchased your access code yet, you can still register in WebAssign for this class. You'll use the class key here, SF College 9201-8317. And when you get to the portion of the registration process that asks for your access code, if you don't have an access code yet, just kind of scroll down on the page and look for the little link that says use trial access or use temporary access. That will give you 2 weeks. So if you're waiting for your financial aid to drop, or if you're waiting for your code to come in the mail, something like that, please still register for WebAssign today. I need you in there today. There's homework in there now. Please get in there today using this class key. This is the unique identifier for our course to make sure you get the right homework assignments, and then enter your access code as soon as you can. If it's not in your possession yet, use the temporary access to register. If you already have it, awesome, go ahead. The calculator rules for this class are pretty strict. So there will be some instances where I tell you on the homework, you're welcome to use Desmos, or on the homework, you're welcome to use a graphing calculator if you have one. But for the purposes of the test and for the vast majority of the homework sets, you're not allowed to use any calculator besides the TI-32XS. This is a scientific calculator. It's not a graphing calculator. It can't do any symbolic manipulation. It can't do any fancy things, and that's very much intentional. We need you guys to learn how to do those things yourselves. So the only calculator you're allowed on the test is this one. You can get them at Walmart for like 12 bucks. You can get them on Amazon for like 9 bucks. That's not a fancy calculator. And if I'm honest, you don't need it. You really don't need it. But I know a lot of people are more comfortable just having a calculator to check their arithmetic. I get that. My arithmetic is not great. So if you would like a calculator, this is the only one you're allowed to use. The other thing you need to have for this class, of course, is a computer. You got to have an up-to-date web browser. Please, 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 please update your browser, whatever you're using. I recommend Firefox. But whatever web browser you're going to use, keep it up to date, because sometimes HonorLock or the various softwares will conflict if you don't keep it up to date. Got to have consistent internet access. And I know this can be a problem that feels like it's out of your control. Sometimes internet goes out at home. Have a backup in mind, right? Make sure if your internet at your apartment or your house, wherever, is spotty from time to time, make sure you have a backup place in mind where you could scurry to quickly and use the web, because if, for example, the internet goes out on the day of a test, there's not much I can do for you. I will work with you, extend timers, etc. But at the end of the day, it is your responsibility to make sure you have access to the internet at the moments when it's critical. Other things you need: functioning webcam. You're not required to have your camera on during class, but you are absolutely required to have it on during your exams. I'll talk about how we're going to proctor exams a little bit later, but you must have a functioning webcam for this class. Course description. It is what it sounds like. This class is meant to prepare you for calculus. So we're going to talk about all the things you need to excel in calculus. Particularly, you need to be comfy with functions. Like I said a minute ago, you need to be comfy with function notation. And we're going to study a whole bunch of functions, kind of as separate families. We'll study polynomial functions, rational functions, algebraic functions, logarithm, exponential, piecewise functions, all kind of in their own stead. And you need to get comfy with graphing in this class. That's one of the big goals. Your success in Calc 1 in particular is highly dependent on your comfort with graphs. So you need to, in this class, learn how to graph functions. And I'll show you a bunch of tricks for that. That's one of the things we're going to focus on. We'll talk about conic sections, inequalities, systems, matrices, and matrix algebra. And a little bit sequences and series. If you want a full detailed list of the course objectives, you can follow that link. It'll take you to this page and you can read these things. Cell phones, this is more relevant for in-person classes. My basic rule of technology is just don't be an asshole. Don't distract other people, right? Just be polite. So in the in-person setting, that means not having Instagram or whatever up and someone behind you like getting distracted by that. In the online setting, what it really means is don't be like messaging people on Discord, GroupMe, whatever, during the class. So if you want to say something to somebody else during class, type it in chat, say it out loud. But please don't be like messaging other people, especially people from the class, while we're meeting. Attendance policy. So I don't have an attendance component for the grade, right? You guys are adults. It's your responsibility to come to class and learn the material. And I'm not going to penalize you if life does something and you can't come to class on a given day. However, I do take roll every day using the Zoom logs. That's why I ask that you use your real name in Zoom. And those attendance records are sent to financial aid people to make sure financial aid gets dispersed. I keep them for petitions processes and things like that down the road. There's lots of reasons why attendance is important, and especially in a 6-week class like this, I can't say how important it is that you come to every class. Don't miss class. Just don't do it, right? Showing up is half the battle, for real. So please show up every day. It's the minimal amount of effort you can put into this. You must come to class. But there is not a grade penalty if you miss. If you do miss a class, feel free to send me an email, Canvas message, ask me what did we talk about, any questions you have, things like that. But please, please, please try to come to class. Do not miss class. Makeups, I try to be super chill about this. If you miss something, just let me know, and I will do my best to accommodate you. If you're going to miss a test, like you won't be here on the day of a test, let me know in advance, and we can schedule the makeup as long as it's within a week of the miss date, right? So if you miss a test, let me know, and I'll get a makeup scheduled for you, but I can't postpone more than a week. And then no graded materials will be taken after the final. That's everything. Makeups, homework, whatever. Homework and quizzes. So I'm going to give you guys 2 homework sets every week, because normally I just do 1 homework set per week, but because this, again, real short class, 6-week class, you're going to have 2 homework sets per week. One will be due on Monday at the start of class. The other one will be due on Wednesday at the start of class. So you need to be doing the homework every single day. You can't put it off until the day it's due or anything like that, for so many reasons. So please do the homework, work on it every single day, and you'll be okay. It's going to be due 2 days a week, Monday and Wednesday, both of those at the start of class. So at the start of class on Wednesday, the homework relevant to Monday and Tuesday's lectures is due. At the class that starts the following Monday, the homework relevant to Wednesday and Thursday's lectures the previous week will come due. And that way you stay on top of the material. If you are late on a homework set or you're unable to complete a homework set, you can submit an extension request in WebAssign, and 9 times out of 10, I will grant that without any sort of question. But if you fall behind in the homework, it will destroy you. I promise you, it will. This class moves so fast that falling behind at any stage is pretty much a death sentence. So please do yourself the favor, get in there today, start on the homework, don't waste time. Exams, 3 midterms, 1 final. So because we're doing everything online right now, I have to proctor remotely. And the way we're going to do that is through a combination of Zoom and HonorLock. So the exams are going to be in Canvas. They're structured as Canvas quizzes. And you will need to go through the HonorLock process to get into those exams. HonorLock will record your screen and your computer's webcam. The other thing that we're going to do, you're going to get on Zoom on your cell phone, set your phone kind of off to the side over here, pointing at your desk, your hands, your lap, where I can see your work surface. I can see what you're writing. And that's how we're going to proctor this shit, right? So HonorLock's going to take care of the screen and the webcam. And then on your phone, you will use Zoom to show me your work surface, your hands, your lap, your work area. That way I can be confident you're not on your phone. I can see what's going on over here. You'd be shocked the shit I've seen. So that's how exams are going to be proctored. There will be 3 midterms and 1 final. The final, again, on the 9th of August at 1 p.m. Same proctoring scheme for the final. A little note about recording. Everything here is being recorded. You saw that notice as you signed into Zoom. I'm going to be posting the recorded lectures to YouTube. So be mindful of that, right? Just pay attention to what's going on. Similar things for the tests, right? Your webcam is going to be recording. Your phone is going to be recording. So just, again, be mindful of what's going on around you. Some dates you want to put in your phone calendar in addition to the final. Obviously, you know, today classes start. The last day to add a class is tomorrow. So if you decide like, oh, I don't want this class, I want some other class instead, you need to add that class between today and tomorrow. The last day to drop this class and get your money back is July 1st. So if you want to drop, nothing shows up on your transcript, you get your money back. It's like it never happened. Last day for that is July 1st. Next Monday, July 5th, the college is closed to acknowledge Independence Day, which this year falls on a Sunday. That will not affect the homework due dates. By the way, you still have a homework due on Monday. Even though the college is closed, we won't be meeting. The homework set that would normally be due on that day is still due on that day. The last day to drop this class and get a W, which is different than a drop with refund. The last day to drop this class, you don't get your money back, and there is something on your transcript, but instead of an A through F letter grade, it's just a withdrawal, is the 26th of July. And there's a little note here that if you want to withdraw beyond that date, you have to go through the petitions process, which is a bit of a laborious process. So you want to make up your mind whether you're going to stay in the class or not by the 26th of next month. The last day of class is the 7th. The final exam, again, is the 9th. And then you'll see your final grade for the course in East Santa Fe by the 13th of August. Those grades, by the way, come from these things. So the homework in WebAssign is worth about 8% of the overall grade. The quizzes, which will also be in WebAssign, are worth about 13% of the grade. The midterms, the exams that we talked about a second ago, there's 3 of those, 100 points each. They're worth a little bit more than half of the grade. And the final exam is worth a little bit more than a quarter of the grade. So you see more than 75% of the grade comes from proctored exams. So this is where you really want to put your time. You want to make sure that these go well. And not surprisingly, the way to make sure those go well is to take the other 2 categories seriously. As long as you're solving the homework on your own independently, you're really doing and getting what you should be out of those, then the tests are going to go great. If you hack your way through the homework using some combination of Symbolab, Photomath, Integral Calculator, favorite bullshit cheat at math thing online, if you hack through the first 2 categories, then the last 2 categories will bite you in the ass. And the last 2 categories, again, where 75% of the grade comes from. So invest your time here, and it will pay off here. The grade scale is the standard one. 90 to 100 is an A. We go down 10 points per grade. And then the top 3% in each category earns the plus designation. So an 87 is a B+. The next page here, this is mostly boilerplate syllabus stuff. Jellos, you don't need to worry about. Academic integrity is what it sounds like. Don't cheat, I'll catch you. You can click any of these links to go to the relevant pages on Santa Fe's website. ADA stuff, if you're registered with the DRC or you suspect that you're entitled to accommodations through the DRC, whether you're registered with them or not, please share that with me. If you're registered with the DRC, you need to go through the formal process and I'll set up your accommodations that way. If you think that you're entitled to some sort of accommodation, but you either haven't registered yet with the DRC or you've tried to register, but they're kind of dragging their feet, I know they can take a while, just again, let me know. I'll set up the accommodations anyway. I don't really care. I'll work with you independent of them if need be. But we need to set that stuff up at the beginning of the term. Accessibility, everything is following legal accessibility stuff. Don't stress there. If you need help with screen readers and note takers, anything like that, again, talk to the DRC. Discrimination, harassment, don't be an asshole. Just be polite to myself and your fellow classmates. But again, you want specific rules, the link is there. Student rights and responsibility, really nice to know what rules you're going to be held accountable for, the sort of things you can get in trouble for, the sort of consequences associated with those. All of that stuff is here at this link. I suggest you take a look at it if you haven't in the past. The big thing on this page I want to talk about is this little extra note on cheating. So I'll tell you a little story. Last fall, fall 2020, one of my Calc 2 classes, I'd noticed cheating on the tests, on the midterms, and I'd taken off points and told them, if this continues, if you do this on the final, I will fail you for the class, I'll pursue a ZF, I'll try to get you kicked out of school, all that stuff. 10 people still cheated on that final exam. And even though I had warned them all previously that I know they're cheating and told them all previously that I will fail you for the class, I will pursue disciplinary action, I'll try to get you expelled, 10 of those motherfuckers still did it. I threw all of them under the bus. Every single one of them got an F. Every single one of them got a trial with Dan Rodkin, and a bunch of them got kicked out, got ZFs, got nasty things on their transcripts. Various different things happen depending on whether it was their first or second or third offense. I promise you, as the third college I've taught at, I promise you, I can tell if you're cheating. I know what the output from Photomath looks like. I know what the output from Symbolab and Wolfram and Integral Calculator look like. If you use those things, I will catch you. Please don't use those things. If I catch you, I will fry you as hard as I can. I have no qualms about that. Here's the deal. If you feel tempted, if it's getting close to the test and you're thinking, I don't think I can do this, or your brain is starting to do that thing where you're like, how can I get away with this? Instead of that, just send me an email saying, hey, I'm stressed. I don't know if I'm ready for this, and I'll work with you. Right? If somebody catches a cold or gets sick, we give them a little bit of time to get better, right? So if you're overwhelmed with anxiety, you don't feel like you're ready for this test, send me an email. I'll work with you. Please don't try to fuck around with this stuff. If you're honest with me, I will do everything I can to help you. If you're dishonest with me, I will try to set you on fire. So please just be real with me, and we'll figure something out. If I catch you cheating, you're going to be in a lot of trouble. You don't want it. I don't want it. You don't want it. It's not going to be good. That's that. Here's the course calendar. You can get a feel for the pacing here. This class is going to move incredibly quickly, like 3-4 times faster than a regular class. We're going to be covering 5 to 6 sections per week, and your first exam is next week. That's how fast this moves. So you really need to be on top of it. But you can see the sections we're going to cover in each week, and then the weeks of the test. So test 1 will be in week 2, test 2 will be in week 3, and test 3 will be in week 5. Like I said, ridiculously fast-paced class. So stay on top of your shit. Come to office hours if you're having trouble. Don't postpone things. Don't shove things down. And keep an eye on this calendar. It's a rough outline. I might change things depending on how quickly you guys are getting through the homework or what I hear in feedback and office hours, email, that sort of stuff. But you can count on us following this pretty closely. And again, the final exam, 8-9. So that's the syllabus. Any questions on syllabus, policies, philosophies, school policies, calendar, grades, that stuff?
I have a question.
Yeah, Jada.
Sorry, allergies. I was wondering, with the book, where would you get the online book?
So when you register for WebAssign, you'll get you'll get access to an e-text there. I can show you what it looks like for me within WebAssign. So here is our course. And then I see here a link that says ebook. If I click that, it'll take me to an electronic copy. So once you've registered for WebAssign, you'll have access to an electronic copy right here. There it is.
And is it reliable? Because I know what is it called with Pearson, the e-textbook didn't work as well.
It's yeah, you make a great point. If I'm honest, I don't really like the electronic book. That's why I keep a physical copy here at my home. So while I haven't myself encountered any reliability issues with WebAssign the way that I have encountered them with Pearson, right? Like my math lab or whatever goes down often and sometimes for a while. WebAssign is more stable. It doesn't go down as often. In fact, I've never seen it go down. But that said, it's an online thing and there's a possibility that it will go down, and the nature of the e-text, it might not be as reliable as having a physical copy of the book. So my recommendation, if you want a physical copy of the book, is to go to this website here, abebooks.com. And search for Stewart's Precalculus and see what we can find. Let's see. So here is the text-only 4th edition for $4. We are on which edition? The 7th edition. So we can poke around and see if there's something better. But you'll be able to find a physical copy of the book. Here it is for about $30–40 if you want it. And I think this is a reasonable deal if you're concerned about the ebook or you want something you can write in, that sort of stuff. abebooks.com is right now the best place I know of to buy these things. But if you find it cheaper elsewhere, I'd love to know. International editions are fine, old editions are fine. The problem numbers won't match, but since all the homework is online, that doesn't matter. So if you want to get a 4th or 5th edition instead of the 7th, that's great. Loose leaf is fine. Just make sure whatever you're getting is something that's in a language you can read. That would be my only concern.
Okay, and with the WebAssign, I have to work a double right after class. So can I get the WebAssign code tomorrow morning?
Sure. Even if you don't have the WebAssign access code, you can still register for the class. So all you need to register for the class is this class key. And then when it asks you for your access code, if you look down towards the bottom of the page, there'll be a little link there that says continue with trial access or temporary access. If you click that, it'll get you into the class. And then once your access code gets in, you can input it. And that way there's no risk of falling behind.
Okay, cool beans. Thank you.
Of course. Any other questions about kind of syllabus, policy stuff, anything like that?
I had a question.
Yeah, Austin, what's up?
You said the test was next week. Is it next Monday?
Great question. I'm thinking probably next Thursday.
Okay, thank you.
And like I said, this is a rough outline. It's subject to change a little bit. What I'll need to do is see how quickly you guys are moving through the relevant homeworks, and then I will let you guys know no later than this Thursday which day next week we'll have the first test. Okay. Yeah, probably next Thursday.
Are tests during the class period?
They are, yeah. This is a hybrid class. This is not a fully online class. And one of the big differences is that instead of having like a big window where you can take the test, you have to take the test during the class time. So the exam will be during class time, and I'll be proctoring you guys individually through Zoom on your phones, in addition to the honor lock proctoring. All right, so yes, during class time. Ainsley, any other questions? All right, let's talk just a little bit more about the web component. So I want to share with you guys some of the things that are here in Canvas. I think only a few things should be visible to you guys in Canvas. Of course, this is our homepage. If you want to come to the office hours, they're Monday through Thursday, 3 to 4 p.m. All you got to do is click this link. This link, just like the link you clicked to join today's class meeting, will enter you into a Zoom meeting. But there will be a waiting room there. Sometimes people want to discuss things in private with me during office hours, grade issues, things around which there are FERPA law restrictions. So if you just click this link, it'll take you to a waiting room. Just please be patient while I work with other students. And as soon as I can, I will admit you. I have a direct link to WebAssign here. You can follow this to get to the online homework, or you can just navigate to webassign.net manually. The other thing, this link for the syllabus, please, 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 if you have not yet, save a copy of the syllabus to your computer somewhere you can find it. Other things here in Canvas, if you haven't used our online tutoring at Santa Fe, it is reasonably effective. Just follow the link that I put there in Canvas, Learning Commons web tutoring section. Come down here to Math and Statistics, and then follow this link to the Learning Commons Canvas page. So the reason I ask you to do it that way is because here they've got the hours. You won't be wondering what's available. And then once you're here, you can click on Math, Sciences, and Business Tutoring. This will take you to the Zoom meeting. Other things that you'll see in Canvas that are useful, of course, the announcements. I'll be posting a YouTube link, a link to the recording of this class session right here in this announcement, and I'll be doing that every day we meet. So I'll have an announcement with the Zoom link, and then I'll update that announcement later in the day with the YouTube link if you need to follow up, clarify your notes, or if you happen to miss class. I don't have anything in the modules section yet, but I will eventually be posting things there, videos from Patrick JMT or other math YouTubers that I think you guys might find useful, links to places like Paul's online notes, and then we have the assignments. So the homework and quizzes section here in Canvas, you don't need to do anything. That's just where I'm going to input your scores. I'll be taking the average of all of your homeworks, putting that in the WebAssign score here, the homework score here. I'll be taking the average of all of your quizzes from WebAssign and putting that in the quizzes category here. But the tests you'll see are also here. So exam 1, on the day of the test, you'll click this link, it'll launch Honor Lock, take you to the test. Afterwards, you will need to scan and submit your written work for the free response questions on the test. My recommendation is that on your phone, you download an app like Cam Scanner. Cam Scanner is free. It produces high quality, high contrast PDFs, just like a scanner would, like a literal physical scanner. If you have one of those, a literal physical scanner, of course, feel free to use that. But if you don't, Cam Scanner is a really good option. And I will need you to scan your work after the test and submit that work separately here in Canvas. So that is a requirement. iPhone users, I think the Notes app is capable of this on its own. I don't think you need a separate thing for that. But especially if you're running Android, or if you want a really genuinely high quality scan, whether you're on Apple or Android, Cam Scanner is my favorite so far. If you find something better, please let me know. But Cam Scanner is the best free one I've found so far. All righty. Yeah, what's
When
up?
it comes after you take the test and you want us to scan our work, how long do we have to turn the work assigned in?
That's a good question. Officially I say 15 minutes, and we'll talk about this more on the day of, or the day before the test. My rule is if the work isn't in there, like scanned and uploaded within 15 minutes of when you submit the test, I will be sussing it a little bit and probably send you a message asking you to explain. But I don't have a hard and fast policy about that. You'll want to keep Zoom open on your phone as you go through it so you can talk to me. But if you run into trouble, like your phone battery dies, or something happens that keeps you from being able to upload the work right away, I'm not going to totally negate it. But the rule is 15 minutes. If it's more than 15 minutes, then you're going to have to explain something to me. Does that make sense?
Yeah, thank you.
And the easiest way to alleviate any issues there is to leave Honor Lock running. If you leave Honor Lock running, then it will continue recording your webcam and your screen. And as long as all I see is you sitting there, scanning the work and getting it in, or struggling with whatever you're struggling with, then I won't be suspicious. But if everything goes radio silent and it takes 30 minutes to get the work in, we're going to have a talk. But that's not usually an issue. So just get it in as quickly as you can, and everything will be fine. All right. Any other questions about the sort of bookkeeping stuff?
I got one more question. I'm sorry.
Sure.
Will there be any type of like I'm trying to think of a word. Like basically like assignments that we'll have to turn in, like we'll have to write in and like turn in type of thing, project type thing?
No, not really. So there's the homework and the quizzes, but those are all online. the only place you have to submit physical, like written work for me in this class is following the tests. Now, if you want to send me pictures of your work, if you're like, I'm not sure I'm doing this right, or can you critique this for me, I'd be happy to. You can always send me a scan or a picture of your work, and I'd be happy to look it over for you. But there is no place besides the written work for the exams that you're required to send me physical written work.
Okay, thank you.
Yeah, of course, of course. Any other stuff like this while we're here? Alrighty, then it's starting to sound like we're at the place where we get to do some mathematics. I'm going to go ahead and clear a little bit of space on my desk here, and we're going to run through the first bits of what I want you guys to be working on this week. I know the start of this course can be a little bit frustrating because it feels like it's reaching way back to stuff you've done in the past, especially if you've taken like 1033 in college algebra. So I'm going to move pretty quickly through 2.1, but let's go ahead and do it just to make sure we all have this common background. So as a general rule, anything you see me writing on the dot cam is something you should write in your notes. Section 2.1 is all about functions. And as you probably know, a function is a relation, a mathematical relation, in which each input is paired with one and only one output. And that definition is a little bit dry because it hinges on this word relation. But the basic way to think of a function is as a machine that takes objects from one set over here, maybe takes an object that I'll call x, the function we would call f, and it sends each one of the objects over here to a single object over here that we call f of x. So contrary to the notation or ideas that may have been kind of planted in your head by overzealous algebra teachers, f of x is not the function. F of x is the particular output associated with the particular input x. The function is just f. Now, the set of all these inputs we call the domain. And the space where all the outputs live is technically called the codomain, but the set of all outputs themselves is called the range. And then the big idea here is that each input, each x, gets mapped to or sent to by the function f one and only one output. So it's not possible for a particular input to get sent to two different outputs. This is useful because it lets us kind of recognize the input from the output. If I tell you I'm looking at f of x, there's no doubt about which input we're talking about that coming from. And that'll be really useful when we're looking at things in terms of graphs.
What's the word that you wrote next to output?
Range.
Oh, okay.
Sorry, capital R, range. So the domain is the set of all inputs. The range is the set of all outputs. There's a bunch of different ways to describe functions. One of my favorite is this thing called a mapping diagram that you see up here. But we can also talk about them in terms of what are called machine diagrams or arrow diagrams. And there's a handful of other ways to describe them as well. So let's just practice a bit with the notation. Sorry, I'm going to turn the page in a second, so I'll give you just a moment here. All right, going to turn the page. One of the things we teach in college algebra is that there's kind of 4 different ways to describe a function. Algebraically or symbolically, which is the way most people are used to. You get a formula. You can describe a function verbally. I could tell you in words what that function does to each input. I could describe a function by giving you its graph, or I could give you a table as long as that table is genuinely complete. Most of the time, we'll be working either with the algebraic description of a function or sometimes the verbal description of a function. So just for example, consider the function f of x equals x squared plus 4. I'm going to do a few things here. I want to describe the function verbally. I want to evaluate a few particular values of the function. So I'll say, let's evaluate f of -1, f of 0, f of 1, and f of 3, just for fun. I'm going to do something here called drawing a machine diagram. But first, let's find the domain and range. Maybe we'll skip the machine diagram. I don't think it's really going to be helpful here. Yeah, this is enough for now. Let's start with this. Okay. If on a test I were to ask you to describe a function verbally, what that means is I want you to tell me in words what the function f does to each input x. So a verbal description of this function, I could say the function f takes an input x, squares that input, then adds 4 to the result. This might feel like a slightly silly thing, but when we talk about a verbal description of a function, what we're really looking for there is an order of operations understanding, right? Everybody remembers PEMDAS? Your order of operations symbolically can be a little bit hard to interpret. I would say for this function, it's not. But sometimes it's not super easy to see what order the operations are being performed in. And when you describe that function verbally, you're required to give this sequence of steps in order. So if you're having a little bit of a hard time evaluating a function, or if you're not entirely sure how to deal with a sort of complicated algebraic expression involving a function, one of the things that's wise to do sometimes is go ahead and describe the function verbally just to yourself to make sure you understand the order that the operations are taking place in. Are there any questions about this answer I've provided here, where f takes the input x, squares that input, then adds 4 to the result? We all understand what I'm saying in purple here? Okay, again, it's not my aim to insult your intelligence. I just got to make sure we all have this common basis of understanding. If I want to evaluate f of -1, that means I'm looking for the output from this function when I plug in -1 for x. I just go ahead and take this algebraic expression and replace x by -1. So it would be -1 squared plus 4. Pro tip, anytime you're evaluating a function, take the input that you're plugging in and put it in parentheses. That will help you a lot with the order of operations, especially when those inputs are more complicated. And I'll show you what I mean in a minute. Following PEMDAS, I need to square the -1 first and then add 4 to that. The square of -1 is -1 times -1, which is +1. So this is +1 plus 4. And +1 plus 4 is 5. Again, it might feel silly to kind of write out all these steps, but I encourage you to mimic my work when you write your solutions to the homework. Organizing your work on the page will help organize the work in your brain. F of 0, similarly, would be parentheses 0 squared plus 4. One step at a time, 0 squared is 0, so this is 0 plus 4, and on a good day, that's 4. F of 1 would be 1 squared plus 4. 1 squared is 1, so this again is 1 plus 4, which is 5. And we've got f of 3 down here. That would be parentheses 3 squared plus 4. 3 squared is 9, so this is 9 plus 4, and 9 plus 4 is 13. So f of negative 1 is 5. F of 0 is 4. F of 1 is 5. And f of 3 is 13. Any questions on what we've done here?
No.
All right, this next part is kind of fun. I want to find the domain and range of f. And this gives me an opportunity to talk a little bit about some rules. So to find domains, I suggest looking for what I call domain red flags. And I always smile to myself a little bit as I discuss this, because there's a cute analogy here. Like if you've ever gone on a date, right? Girls, you go on a date with a guy, he tells you he hates his mother, that's a fucking red flag, right? You gotta watch out. Functions have red flags, right? There are some things you see in a function you need to watch out. So what are the red flags for an algebraic function? The first one, variable stuff downstairs in a fraction. It's a red flag. If you're looking at the algebraic representation of a function and you see some x's or variables, whatever t's, downstairs in a fraction in the denominator, that should set off a little alarm in your head and say, oh, I need to be mindful of that when I'm thinking about the domain. So your first sort of domain red flag is any variables downstairs in a fraction. The rule here, you need to make sure, so I'd say, any inputs which make the bottom equal to 0 must be excluded from the domain. All right, that's the rule. Other domain red flags? Any variable stuff under an even root. Right, so an even root is like a square root or a fourth root or a sixth root. If you have any variable stuff under an even root, you got to watch out, because you can't take the square root of a negative. You can't take the fourth root of a negative or the sixth root of a negative. So any inputs which make the inside, there's a name for this part called the radicand. Make the inside of an even root negative. These also have to be excluded. Oops, sorry, my pen is not very nice. must be excluded from the domain. All right, so that's the rule there. And right now, these are the only red flags you guys have to concern yourselves with. I will give you some more as the semester wears on. But for now, you just have to be on the lookout for any variable stuff downstairs in a fraction or any variable stuff underneath an even root. If you have some variables downstairs in a fraction, make sure the bottom is not 0. If you have variable stuff under an even root, make sure the inside of that root is not negative. The other rules I'll be adding down the line have to do with logarithms. The inside of a logarithm must be positive. But if we return to this question, we want to find the domain and range of our function f. I'll hold here for a minute on the red flags. You can write down anything.
What is that word beside inside?
Radicand. R-A-D-I-C-A-N-D. It's a fancy term for the inside of a radical. Right? You've heard that like check symbol, the square root symbol called a radical. The word for the inside of that is the radicand. Any other questions about these domain red flags? These are going to be very important as the semester goes on. All right, then let's look at our function here. I'll do this off over here. So our function is x squared plus 4. F of x equals x squared plus 4. Do we have any red flags of the first type? Do we have any variable stuff downstairs in a fraction? Yeah, I see Benjamin shaking his head no. Right?
No.
Yeah, no fractions here at all, right? Everything is upstairs. So we don't have to worry about any of this stuff. Do we have any variables under even roots? Do we have any roots at all?
A square root, but that's it.
So let's be clear. This is a square, not a square root, right?
Oh,
The square root would be like this.
okay.
And then the piece that's under here, that's the thing called the radicand. So here we've got a square, but no square roots. So we don't have any red flags of the first type, and we don't have any red flags of the second type. That means we're good to go. What do I mean when I say we're good to go? Well, if there's no red flags, and the red flags are what tell you you need to kick some numbers out, then there aren't any numbers we need to kick out of our domain. So the domain is there's a bunch of different ways to say this. You could call it all real numbers. Which is the same thing as the interval from negative infinity to infinity. And there's also a special symbol for this, if you want to be fancy about it. This is called a Blackboard bold R, and that's the fancy symbol for all real numbers. You can type any one of these, and I would be happy with them. The type of function we're looking at here is a polynomial. And generally, this is the same result for all polynomials, because all polynomials are built out of non-negative integer powers of x, linear combinations of non-negative integer powers of x. So necessarily, any polynomial will have domain all real numbers. It's a nice fact. Well, I'll remind you of it when we talk about polynomials in particular down the road. So that's the domain. We do also want to be mindful of the range. How can we find the range of this function?
The intercept. Like the B, like the.
So if this were a linear function, that might help us a little bit. I'm curious what you mean. Can you go into a little more detail for me, Jada?
I'm sorry. I just thought that like since like it's x squared plus 4, it hits the line at 4
That's
y,
right.
or you could whatchamacallit, you could replace the you can replace the like you can substitute the solve for y or x, something like that. I'm sorry.
No, don't be sorry. Don't be sorry. High pressure, weird environment. You're
Yeah.
100% correct. You're 100% correct. This 4 is going to be meaningful in the range. And it sounds like when you're talking about the function starting at 4, it sounds like you're thinking about the graph, which is great. That's where I was going to go with this. And it gives me an excuse to show you one of my favorite tools. I don't know if you guys have seen this before. Whoop, I typed a P there. So this is Desmos. And if you haven't used Desmos before, I encourage you to start using it now. You're not allowed a graphing calculator in this class on tests, and I don't want to encourage you to buy one of these clunky pieces of shit, but I do want to encourage you to start playing around with Desmos. Any homework set that asks you about the range of a function, you're welcome to use Desmos on, and I encourage you to use Desmos on. The easiest way to get the range of a function is to use a computer or a tool to look at the graph of that function. So like Jada was saying, the graph of this function, if you graph this, so I'm typing X here, and then Shift-6 to type a caret, the kind of up arrow to get into the exponent. And then I hit the right arrow to get down out of that exponent, and then I type +4 to get this. This is the graph of this function. And remember what we're looking for when we talk about the domain and the range. The domain is the set of all the x values that are along this graph. And if I zoom out enough, you'll see that even though it gets really, really tall, there is somewhere up there a point associated with x equals -500. I've just got to go way, 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 way up. But we already found the domain. We have algebra tricks for finding the domain. We haven't yet found the range. The range is the set of all the outputs on the graph, which is the set of all the y values on the graph. And that's much easier to tell looking at the actual graph than the domain. So let me really quickly transcribe this graph onto the document camera over here. I'll hold on this for a moment in case there's anything I need to write, just about 10 seconds more. You might want to make a little note here. Here's where we actually solve for the domain. Didn't require too much work. We just asked, does this function have any of those red flags? The answer was no, so the domain is all real numbers. For the range, I'll turn the page in a second. We'll look at it. We're going to want to look at the graph. 5 more seconds. Okay. So the range, we're going to look at the graph. Fx equals x² + 4. We're going to talk a lot more about graphs down the road, but for now, this is sufficient. You're welcome to use Desmos here. It's my x-axis. This is my y-axis, and this is the graph y equals f of x. The range is found by sort of smooshing the graph down onto the y-axis. So I kind of take every point that's on this graph and I smoosh it onto the y-axis. When I do that, if I take this point right here, which is 0, 4, and smoosh him onto the y-axis, he doesn't move. He's already on the y-axis. But if I take any of the points over here and smoosh them onto the y-axis, I'll get all of this stuff. So I like to use a highlighter here. If I highlight the projection of the graph onto the y-axis, I get this. And that interval of y values includes y equals 4 and everything larger. Right? There's a point over here that will get smooshed here. There's a point up here that will get smooshed here. And because the graph goes up and up and up forever like this, the range is this interval of y values 4 to infinity. Now there's another way to do this. Another way to think about the range. If you know a priori, if you know prior to our discussion today, we know that x squared is always greater than or equal to 0. That implies, and that's what this arrow means, implies, that implies that x squared plus 4 is greater than or equal to 4. All right, I'm just adding 4 on both sides of this inequality. And this piece right here is f of x. So what this inequality says is that f of x is always greater than or equal to 4. So the outputs from my function f, which remember are f of x, are always bigger than or equal to 4, meaning they have to come from this interval 4 to infinity. This inequality on its own doesn't quite justify the range being 4 to infinity, but it tells us that the range must at least be a subset of 4 to infinity. I prefer to think of it in terms of the graph, and I think you'll find that to be the case also. But this is a perfectly valid way to think about it also. We will talk more about inequalities as the semester goes on. So I just want to introduce or encourage you to be aware of this other way. Any questions on finding the domain and range of this particular function? All right. And we are going to bravely move on. I'll talk a little bit about piecewise defined functions. A function is said to be defined piecewise if it's made up, that is, the function is made up of several different functions kind of glued together. In other words, if I take a bunch of little functions and I interpret them as pieces of a larger function. Usually the way we do this is by kind of splitting up the domain. I think the best way to introduce you to this concept is through examples. Let me just say here a piecewise function is a function made up of combinations of other functions. And then we'll look at an example. I would like this example to be a problem that we have to solve. So I'm going to say evaluate the piecewise function below at x equals -3, -1, 0, 2, and 5. All right. So I'm going to give you a function. I'm going to say I want to evaluate this function at a bunch of different inputs. But that function is going to be defined piecewise. Oh, sorry about that. All right. So here comes our piecewise function. Again, I'll call it f of x. This is the notation. We use a curly brace. We say f of x is equal to curly brace. Let's say if x is less than 2. Let's say it is equal to x squared. If -2 is less than or equal to x is less than or equal to 1. And we'll say it's equal to 2x if x is greater than 1. Sometimes when you see these written, they won't have the word if here. It'll just say 1 minus x and then x is less than 2. So I like to insert the word if here, especially when you're first learning these things. A quick note on inequalities. This is the less than symbol. This is the greater than symbol. And there are different ways to remember them. I think this is the class where you really need to internalize that. Since we are in Gainesville, the cute way to remember this is that the symbol always eats the bigger number. So here you see x and then this symbol and then -2. Since this symbol kind of looks like a mouth, right? Munch, munch, munch. It's eating the bigger number. So I'm saying here that x is smaller than -2, or -2 is bigger than x, because it always munches the bigger thing. So the one that's facing this way is less than. The one that faces the other way is greater than. This is munching the x. So it says x is bigger than 1. And then in between here, these are less than or equal to with the line beneath. So let's talk a little bit about this function. I've been told I just want to evaluate the function at these numbers. So that means I want to know what is f of -3. That's the first thing I need to find here. That is the function f of x evaluated at x equals -3. Since this x value is -3 and -3 is less than -2, I will use this guy. Basically, what this notation says is that my function behaves like this if the input is less than -2. Behaves like this if the input is greater than or equal to -2 or less than or equal to 1. If -2 is less than or equal to x is less than or equal to 1. And behaves like 2x, behaves like this guy if x is greater than 1. So the function f is a combination of these functions. And his behavior is split up over the domain. So f of -3 is going to come from this first guy because -3 is less than -2. So I'll use the 1 minus x piece here. That means this is going to be 1 minus -3. Is everybody comfortable with why I'm using this first piece? If you have questions, this is the right time to ask. I promise you, if you're curious, others are too.
I have a question.
Yes, please.
So, are those gonna be given or do we have to figure them out somehow?
The inequalities?
Yes, the
These will be
inequality.
given, yeah. So this whole thing is the definition of the function. And if I didn't give you these, you wouldn't have a defined function. So anytime you're given a piecewise function, you will have this whole highlighted piece here.
Okay, thank you.
Now, when we go to evaluate the function at these numbers, we have to figure out which of these three categories that input falls into. So when I go to evaluate my function at x equals -3, I need to ask, does that fall into this category, or this category? Is -3 bigger than 1? No, it's not. So I know I'm not going to use this. Is -3 between -2 and +1? No, it's not. So I'm not going to use this. Is -3 smaller than -2? Yes, it is. And that's why I know to use this. Does that make sense?
Yes, it does. Thank you.
Awesome. Other questions on this so far? I'm just going to go over this in purple because that's our theme. I'll put solutions in purple. So because -3 falls into this category, that x value is less than -2. I'll use this first piece of the piecewise function. And 1 minus -3 is the same as 1 plus 3, which is 4. So f of -3 is 4. Next, I was told to evaluate the function at -1. Which of these three categories does -1 fall into? Let's say the first category, the second category, or the third category.
Second category.
Excellent, yeah. -1 is between -2 and +1. So I'll use this guy, which means f of -1 is -1 squared. And the square of -1 is +1. So f of -1 here is +1. I was also told to evaluate f of 0. And 0 is also between -2 and +1. 0 also falls into this category. So again, I'll be using the x squared here. F of 0 is then 0 squared, because when I replace x by 0, that's what I get. And 0 squared is 0. F of 2. Here, 2 does not fall into this category. 2 is bigger than 1. So I'm actually in this third piece now. So I'll be using this formula. F of 2 is then 2 times 2, which is 4. And f of 5 is 2 times 5, because again, 5 is bigger than 1. So 2 times 5, that's 10. So this is what we get when we evaluate that piecewise function at these particular inputs. Any questions on how we're getting these answers out for this example? Okay, just for fun, and because we're going to be talking about graphing a lot, let's graph this guy. So I'll do this over here, and it's not going to be a super rigorous graph. I want to give you a feel for what this thing looks like. I know that my function changes behavior at -2. So I'll mark here -1, here -2. And it changes behavior again at 1. So I'll mark 1, +1 over here. If x is smaller than -2, then this function behaves like 1 minus x. So, for example, at -3, we already saw that the output from this function is 4. So I have the point -3, 4. And the slope of this line, 1 minus x, is -1. So we'll be going down 1 for every 1 we go over. And we're going to do that until we get to -2. So that's not too far. We're just going to come over to here. And I'm going to use an open circle here. I'll talk more about graphing these functions when we get on to the next section. Then between -2 and +1, my function behaves like x squared. And the graph of x squared from -2 to +1 is this parabola. And then for x's which are greater than 1, my function behaves like 2x, which is a line with slope 2.
Wait, so it's it's 3 different graphs in one?
Exactly.
Oh, okay.
Yeah, that's kind of how piecewise functions work. And we will spend some time talking about graphing piecewise functions when we get to the section on graphing. But basically, you take these 3 graphs and you kind of chop them up and then glue them together. It's pretty cool stuff. But again, for the purposes of the example we're looking at for the 2.1 problem, the section that we're on right now, this is all you would need. The graph is just for fun. Okay. I want to do one more of these evaluating function problems, but this time I want to use some more complicated expressions. Let's do something like this to start.
Wait, I'm sorry. Do you mind showing the graph again?
I'd be happy to. Sure. Here you go.
Thank you. Okay, that's it.
And I'll hang out here for just a second. Okay. Actually, let me say, oh, yeah, we'll do it like this. X equals 0, x equals 1, x equals a plus 2, and x equals a plus h. Same sort of thing. I'm giving you a function. This time there's no piecewise weirdness. And I'm asking you to evaluate this function at a few different inputs. So the first input is x equals 0. The second input is x equals 1. The third input looks a little weird. It's a plus 2. So there's another symbol here involved in this third input. and then the number 2. And the fourth input, I'm asking you to evaluate it at a plus h, which is even a little weirder. I really want you guys to get comfy with these last 2 things, because these are going to be building blocks for stuff we talk about real soon. But these first 2 we should be able to manage pretty well. F of 0 is what I get when I plug 0 in, right? So that's 0 over 0 minus 1. And again, you need to be careful about the order of operations. Fraction bars always have these sort of implied parentheses. And when you go typing things mathematically, when you go typing into whatever computer algebra systems, calculators, tools you like to use, which I know you will use from time to time, make sure you remember that fraction bars have implied parentheses. It's always the whole top in parens divided by the whole bottom in parens. Now upstairs here, 0 is just 0. Downstairs here, 0 minus 1, that's negative 1. What happens if you take 0 and you divide it by negative 1? Can I do that?
No, yes, it's 0, right?
Good, very good. You can divide 0 by anything, but you can't divide anything by 0. So a 0 upstairs is fine. 0 divided by negative 1, that's 0. No problem there. What happens as I try to evaluate this function at 1? Well, then I'd have 1 divided by 1 minus 1. Now, I'm not going to write the parentheses here, but just remember there's implied parens. Simplify the top and bottom on their own first. Upstairs, 1 is just 1. Downstairs, 1 minus 1 is 0. Is this okay? Yeah, I see
No,
Ben-
It
Benjamin.
would be undefined.
Very good. Yeah, Ainsley and Jada are both correct, along with Benjamin there. Cannot divide anything by 0. Right? Dividing by 0 is not allowed. This would be, you can call it undefined or DNE. I think often WebAssign asks for DNE when something is undefined. Or if you've got any computer programmers in here, this is NaN, not a number. Can't do it. No good. Cannot divide by 0. So certainly I can take $0 and distribute it evenly over 5 people. Everybody gets $0. You can divide 0 by anything, but you can't divide anything by 0. Okay, moving on. If I want to evaluate f of a plus 2, here we need to be a little careful. Same thing though. I'm going to take x. Everywhere there's an x in this expression, I will replace it by parentheses a plus 2. So I get paren a plus 2 divided by paren a plus 2 minus 1. That's always how we start. If I ask you for f of dog shit, you will replace x by parentheses dog shit divided by parentheses dog shit minus 1. All right, always use the parens. You can plug whatever the hell you want in here. Just make sure you're following the recipe and always using your parentheses and obey the order of operations. Upstairs, parentheses a plus 2. There's nothing multiplying this. There's no power here. Sorry. So the top is just a plus 2. Downstairs, a plus 2 minus 1. Again, there's nothing I need to distribute. There's no power I need to FOIL. So a plus 2 minus 1 is a plus 2 minus 1, which is a plus 1. Before we move on, is f of a plus 2 the same as f of a plus 2. Or maybe f of a plus f of 2. Or maybe neither of those.
Neither.
Excellent. Ainsley is correct. Why?
Because
Because we don't know what. Oh, sorry.
That's okay. That's okay. I want to hear what everybody has to say. Let's let Ainsley answer first and then we'll move on.
because for the a plus 2, when it's both in the function, you're doing the whole thing on top and bottom for like this equation. But when it's plus 2, you're just adding plus 2 to the final of FA.
Great. Very good. And then who was my other person who answered there? Was that? I'd be curious.
That was me. It was me. I
Okay,
was just
yeah, what
saying
were you
we
saying?
don't. I was just saying we don't know what A is, so we can't really solve it.
Fair enough. It's true that we don't know what A is. And you may bring up a really good point that depending on what A is, one of these may or may not be true. But in general, if I'm just letting A be a symbol, algebraically, they're not necessarily the same. So for shits and giggles, f of A plus 2, like this, would be A over A minus 1. That's f of A plus 2. Like that. F of A plus f of 2 would be, I need to find a better purple pen. F of A plus f of 2 would be A over A minus 1 plus 2 over 2 minus 1, which is A over A minus 1 plus 2. So in this case, these two turn out to be equal to each other, but neither of them are equal to this. And in general, none of these things need to be equal to each other. So when you're asked to evaluate f of some shit, remember, always just plug that shit in for x. Don't try to get fancy and assume it's anything like these. In general, the answer is neither. Okay, one more to go. We want to know, what is f of a plus h? Well, f of x is x over x minus 1. So this would be parentheses a plus h divided by parentheses a plus h minus 1. And is there some simplification I can do here? Sure. Fun question, can I cancel the a plus h's?
No.
Yes. Oh,
I have canceled the a plus 2's here.
yes, you can. I thought.
So the answer here is no. And the reason is you can only cancel in a fraction common factors between the top and the bottom. A plus h is a factor of the top. The top is a plus h times 1. But a plus h is not a factor of the bottom. So here's the rule I would beg you to consider. Whenever you're trying to cancel things in a fraction, factor first. If your immediate step before that was not factoring, don't cancel. So we cannot cancel these because a plus h is not a factor of the bottom. This 1 right here doesn't have an a plus h to give. So if you could factor a plus h out, then you could cancel it with the top. But because we cannot factor it, we cannot cancel. What we can do, and the only thing we can do, is write this as a plus h divided by a plus h minus 1. That's it. I'll make a note here. Cannot cancel the a plus h's because a plus h is not a factor of the bottom. Only common factors can be canceled. It kind of looks like we should be able to cancel them. Just the way things are written, it kind of suggests or makes us want to cancel them. But we cannot cancel them here because a plus h is not a common factor. Okay. Let's see, do I want to beat to death any more of that? I think we're probably feeling okay. Maybe you guys could just tell me a little bit. How do you feel about this problem? Are there any subtleties here? Anything that you would like to look at more carefully? Anything that you're uncomfortable about? And don't be shy. This is what we're here for.
I think I'm okay with that equation. I think the only thing that's like making me a little uneasy is the piecewise,
Piecewise stuff, yeah.
Mm.
Maybe we could look at another example with a piecewise function then. Let me see. Yeah, there's an example in your textbook here that we could look at. We've got one more example with a piecewise function, and then we'll move to the next little topic here. How late do I have you guys? Remind myself. I forgot.
250.
250. Oh shit, no, we're almost out of time. Okay. We'll look at one more example of the piecewise function, then we'll call it a day for today, okay? So let's look at a nice simple one. I'll use some different symbols here. Let's evaluate the function c of x, which is defined piecewise to be 39 if x is between 0 and 2, and 39 plus 15 times the quantity x minus 2 if x is greater than 2 at a few different values. X equals 0.5, 2, and 4. And just for fun, at the end again, we'll draw the graph. The first thing I'm asked to find, if I want to evaluate this function at x equals 0.5, that means I'm looking for c of 0.5. And so I need to ask myself, which of these two categories does 0.5 fall into? Is 0.5 bigger than 2?
No.
No, it's not, right? Is 0.5 bigger than 0 but smaller than 2?
Yes.
Yeah, it is. Okay. So this would just be 39 because 0.5 is between 0 and 2, i.e. 0 is less than or equal to 0.5 is less than or equal to 2. That x value, the x value x equals 0.5, falls into this category. So I would use this formula. We want to evaluate next c of 2. Which one of these two categories does x equal to 2 fall into?
The first one, because it has the less than or equal to 2.
Excellent, right. 2, if you plug x equals 2 into this inequality, you get a true statement. 0 is less than or equal to 2, good. And 2 is less than or equal to 2. And you can check that it doesn't fall into this one, right? 2 is not strictly greater than 2. So C of 2 would also be 39. So again, when I want to evaluate a piecewise function, I check which one of these inequalities is satisfied by the x value I'm plugging in. Finally, C of 4. I need to check which one of these does x equals 4 satisfy. 4 is not between 0 and 2, but 4 is bigger than 2. So I'll use this formula. So that means the output here would be 39 plus 15 times 4 minus 2, which is 39 plus 15 times 2. And following our order of operations, 15 times 2 is 30. So that's 39 plus 30, which is 69. So C of 4 is 69. And right now, these are the only sort of things I'm requiring you to be comfortable with regarding piecewise functions, just plugging in numbers, knowing how to plug numbers into an expression like this. But very soon, I'll be asking you to graph them. Ainsley, did you want to say something?
Oh, sorry. By any chance, can you show the graph just so we can see how it looks like?
Yes, that will be the last thing I do here. So for our very, very final thing today, I'm going to go ahead and graph this function for you. If 0 is less than x is less than or equal to x is less than or equal to 2, then this function c of x is constant. It's equal to just 39. Now I'm going to mark this as 39 on my vertical axis. And x 0, x equals 1, x equals 2. There it is. So the constant function is just a horizontal line, right? Like y equals 5 is a horizontal line. C of x equals 39 is a horizontal line. And because in my definition here, I have less than or equal to at 0, I'm going to use a filled in point there. Because at the right end point, I have a less than or equal to at 2, I'll use a filled in point there. Now, if x is greater than 2, my function behaves like this line. And there's a bunch of different ways to try and figure out what this line looks like. Here's one way to do it. If you plug in x equals 2, this is 15 times 2 minus 2, or 15 times 0. So when x is equal to 2, this is actually equal to 39 also. And then the slope of this line is 15. If you were to distribute, you'd have 15x minus 30. And so the coefficient of x is 15. So I'll just draw this like this and say that that portion has slope 15. And I'll leave it at that for now. So this would be the graph of this function. For fun, the domain here. Sorry, I know I said that would be the last thing, but I just can't help it. The domain here would be 0 to infinity. I don't have anything that tells me what to do if I want to plug in an x that's smaller than 0. This tells me what to do if x is between 0 and 2. This tells me what to do if x is bigger than 2. But if I plug in x equals -1, I got nothing that tells me what to do. So -1, -1/2, -pi over 7, not in the domain. My domain is just 0 to infinity. And my range, who can tell me the range of this function graphed here?
39 to infinity.
Excellent. Alrighty, gang, that's all I've got for you today. I really appreciate you coming, participating. It means a lot to me. Please continue to do that. If you weren't quite ready to answer questions today, I understand, but I will start at least threatening to cold call people tomorrow. So I want to encourage you, continue coming, continue participating. Please use your real name as it appears on your Santa Fe ID when you sign into Zoom. That way I can mark you as attended using the Zoom logs. That's how I take attendance. If you missed anything at the start of class talking about syllabus, policies, grades, any of that shit, I'll be posting this recording to YouTube and sharing that link with you on Canvas in the same place you found the link to join the class. I will just update this announcement with a YouTube link in a few minutes here. Any questions in parting?
Will
No.
we be able to get the YouTube link? Like, where would we be able to access that?
So I'll show you what I did for my other class this morning and you'll be able to see. Earlier this morning, I taught a differential equations class. After I uploaded the video to YouTube, I just took that same announcement with the Zoom link and added the YouTube link. I'll be doing the same thing for your class. So if you come back to that same announcement that you clicked to join the Zoom meeting today, in about 15 minutes, you'll see the YouTube link right here. I'll just be adding it to this announcement. Any other questions? Okay, I do have an office hour today from 3 to 4. If you want to come talk to me there, you know how to do it. Just go to our home in Canvas and click to join link right here. Otherwise, I will see you guys tomorrow. Okay, I hope you have a lovely rest of your day. Please get into WebAssign. Get in there today and start on those problems. That way it doesn't overwhelm you.
Thank you.
I have a question about the homework as well.
Sure.
So I know how you said like on Mondays you'll sign work and then you'll want to or you'll have the assignment due on Wednesday. The homework right now is due on next Monday.
Yes, this week is the only exception to that rule,
Okay.
because I know that it's going to take a little bit of time. People can still add and drop the class. I didn't want to have something be due while you were still able to add and drop. So this week and this week only, you'll have until next Monday to finish the first homework set.
Got it.
All righty. That's it from me, guys. I hope you have a lovely rest of your day. Please, again, get into WebAssign. Don't slack on that. This class moves so fast, you'll fuck yourself real hard if you don't start on that right away. I encourage you to not do that. Get in there, get started. If you have trouble, let me know. I'm here to help. Otherwise, I'll see you tomorrow.
Thank you.
Thank you.